Hey guys, today is the very first day of notes for geometry. We are starting out with Unit 1A, Tools of Geometry and Pythagorean Theorem. The very first thing that we are going to talk about is the Pythagorean Theorem. Our goal for today is you can use the Pythagorean Theorem. If you'd like to follow along in your book, I will always put the chapter and section number next to the goal so that you're able to find it. So this is Chapter 8, Section 2. So the Pythagorean theorem, I know you've learned this before, but just to review it, in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So that sounds like a lot, but let's break it down. So in a right triangle, so remember a right triangle, it's basically a triangle with a right angle. So for example, this triangle, triangle ABC, has a right angle, angle C. It says the sum of the squares of the lengths of the legs. So sum, remember, means addition. You add the legs together. And you also have to square the legs. So the legs are the two sides of the triangle that make the right angle. In this case, side A and side B together create the right angle. The side that's across from the right angle, in this case side C, this is called the hypotenuse. So what this is saying is we take the legs, square them, so we have A squared and B squared. Then it says we have to add them together, and it says that will be equal to the square of the length of the hypotenuse. So that will be equal to C squared. So with symbols it says if triangle ABC is a right triangle with right angle C, then we could say A squared plus B squared is equal to C squared. What's super important about this is you must know that C squared has to be the hypotenuse. A and B can be switched out. The legs, the order of the legs does not matter. However, it has to be equal to the square of the hypotenuse. Let's try an example. This says find the value of x. So we'll focus on this one first. Okay, so in this triangle, the first thing you want to do is identify what side is the hypotenuse. It's always across from the right angle. So in this case, x is the hypotenuse. That means that the lengths of the legs are 6 and 15. So what we need to do is set up the equation. So we know A squared plus B squared is equal to C squared, where C is the hypotenuse. So we can plug in 6 for A, 15 for B, and x for C. You could have plugged in 6 for B and 15 for A. It does not matter. Now the next thing we do is simplify. So 6 squared is 36. 15 squared is 225. Next, we can combine our leg terms on the left side, so add those together, it gets you 261 equals x squared. Now to solve a problem where it has x squared, remember we normally square root both sides, and normally we put plus or minus, because it could have been a positive or a negative number. However, think about it, in a triangle, could the length of this side of the triangle be negative? No, it cannot be a negative length of a triangle side. That doesn't really make sense. So from now on, for these problems, you don't need to include the plus or minus because technically the side could not be negative in this case. So what we have here is we have square root of 261 equals x, because remember the square root and squared cancel each other out. So now we want to see if we can simplify this radical. We practiced this a ton in class last week. So we're going to find the biggest square that goes into 261. The largest number that goes into 261 that's a perfect square is 9. It goes in 29 times. 9 times 29 is equal to 261. Once you figure that out, then you can take the square root of 9, which is 3. So our final answer is 3 square root of 29 for the side x. You could also get an approximate answer by plugging in square root of 261 to your calculator. So if you wanted to do that, or depending on what the problem is asking you, you could find that as well. Let's try another. So on this triangle, we have the legs are 9 and x, and the hypotenuse this time is given to us 11. So the difference between this problem and the last problem is that this time we're finding one of the legs. But it's going to work the same way. So we're setting up the equation a squared plus b squared equals c squared. So fill in our legs. The leg values, the lengths are x and 9. The hypotenuse length is 11. Now we need to simplify. So we have 9 squared is 81, 11 squared is 121. Make sure you're following the order of operations correctly. Now we're trying to get x by itself, so we need to move 81 to the right side of the equation. We can do that by subtracting 81 on both sides. When you subtract 81 on both sides, you should get x squared equals 40. Now remember, just like in the last problem, to get x by itself, to get rid of the squared, we need to square root. And like I said, you don't need to include plus or minus for these problems since the leg, its length could not be negative. The last step is to simplify. This time the largest square that goes into 40 is 4, and it goes in 10 times. The square root of 4 is 2. So our answer is x is equal to 2 square roots of 10. If you wanted to find an approximate answer, you could plug in square root of 40 into your calculator. The square root of 40 is equal to 6.325. This is sometimes helpful to find an approximate answer because notice that the hypotenuse is always the longest side. So on this answer, we got 6.325 as an approximate answer. You can always just make sure that it makes sense. The hypotenuse should end up being still the largest value for the lengths of the sides of the triangle. If you got an answer like 12 or 15, something larger than 11, you need to go back and double check your math because something went wrong there. Another thing that I want to point out is notice on these problems how I have been keeping my equal signs lined up for the most part. I want you to try your best on every problem. Make sure you have your equal signs lined up. If you keep your work organized and neat, it is so much less likely that you are going to make a mistake. So try to keep your work organized, nice and neat. Right below this, you'll see a practice problem. I would like you to go ahead, pause the video, and please try those 2 practice problems on your own first. All right, so here are the answers to those practice problems. The first one, you can see the work there. For the second one, however, you do not see any work. This is our question or our problem of the day. So what this means is I need you to tell me the answer to this problem without me showing you the work first. And we will review this problem in class tomorrow. I'm going to label these hypotenuse for you so you know, just in case. So yeah, we're going to go over that problem tomorrow. Check over your answer for A though. Alright, the next thing we're going to go over are called Pythagorean triples. So Pythagorean triple, the definition of this is a set of 3 non-zero whole numbers, A, B, C, such that A squared plus B squared is equal to C squared. So basically it's 3 whole numbers. Whole numbers mean there's not a decimal after it, and it's positive. And the 3 numbers are the sides of the right triangle. So for example, these are just really common ones that you'll see, 3, 4, 5 is extremely common. I would really love for you to have that memorized because it appears so much in geometry. If you have this memorized, then let's say you had a triangle with the sides, the legs 3 and 4. You can just think, oh, I know a Pythagorean triple that has the sides 3, 4, 5, so I know the hypotenuse is 5. Another thing that this helps with is the triangle can also be magnified. So for example, if you look down here at the bottom, if we take our 3, 4, 5 triangle and we multiply all the sides by 2, that gets us a 6, 8, 10 triangle. You might see this one up here too. Or if you multiply all the sides by 3, this is another common one, a 9, 12, 15 triangle. It can go on and on. I listed out the times 2 and times 3 for all these common triples. And I listed out even times 4. But it can go even larger than that. You could multiply your triangle by 5, 6, etc. Obviously, you're not going to have all those memorized though, so I just listed out times 2 and times 3. You don't need to memorize these. However, I would really, really highly suggest memorizing the 3, 4, 5. Okay, let's try one more example for today. So this says, Damon is locked out of his house. The only open window is on the second floor, which is 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid some bushes, what length of ladder does Damon need? Okay, so I went ahead and I drew this beautiful picture. However, notice that it's a little bit hard to work with. So I would not suggest, when you have a problem like this, of course you need to draw a picture. I would not suggest making it a nice picture like that. So we need to just do the minimum here. We have the ladder, we have the ground, and the house. So always you can assume that if you have a house or a building or some structure like that, you can assume that it creates a right angle with the ground. We know that the ladder base is 5 feet from the base of the house. And we know that this top window is 12 feet from the ground. Now we can call this L for ladder, you could call it X, whatever you want. And I notice right off the bat that this is one of my Pythagorean triples. So I know that this is my 5, 12, 13 triple. So I can go ahead, I already know the answer is C13. However, if you do not know that right off the bat, you could go ahead and use Pythagorean theorem. So a squared plus b squared equals c squared. So I would plug in the legs are 5 and 12. My hypotenuse is L for the ladder. Now I can simplify this. I have 25 plus 144 equals L squared. That gives me 169 equals L squared, which means the square root of 169 is equal to L. And of course, the square root of 169 is 13. So either way, you can see how much time that will save you if you do know your triples, but you can always get the answer using Pythagorean theorem as well. That's all I have for you guys today. Have a great night.